Okay, just want to talk about the swing drive unit here and talk about how this excavator swings and what's involved in this. Sometimes called a swing device, sometimes it's referred to as a swing motor, but it's basically a bidirectional hydraulic motor on top here. Here's the two work port lines coming in, very short lines because they run to the swing function on the directional control valve. And then that motor has a spline shaft that plugs into a reduction unit, gear reduction unit that drives down to the pinion. Because it's an axial piston unit, there's also K-strain coming out of it, and again that connects with the K-strain coming from the travel motors, connects together, and then runs through this hose back to the tank. There's also a line on here called the swing makeup or swing anti-cavitation line, and it has its own, it's again a low pressure hose, but it doesn't run back to the tank. It'll actually tee into the system just upstream of the oil cooler. So where this line runs out to the oil cooler, we've usually got about 75 or 80 psi back pressure. So on the back of the valve is where that makeup line connects. Now we've got a cutaway here of a swing motor, swing drive unit. This is again Hitachi Deere, very similar but different manufacturer than the one in the 307, but about the same size. This one I think was out of a 9-ton machine and has similar operation. So again, there's a hydraulic motor up here. You can see it's an axial piston motor. They've actually cut the barrel open so you can see the pistons and you can see the slippers riding on the swash plate. However, I'm hesitant to call it a swash plate because it is on an angle in there, but there's no bearings and it doesn't change its angle. This is not a variable displacement motor. This is just a bidirectional fixed displacement axial piston motor. So not all piston pumps and motors have to be variable displacement, and this one isn't. So you still can get variable speeds though, because you can control your swing pilot joystick in the cab that's controlling a DCV spool that's proportional, that's then sending oil out the work ports of the DCV spool to these two ports on the motor. So these are our A and B ports. I don't know which one would swing clockwise and which one would swing counterclockwise or left and right, but these would connect to our directional control valve, and the directional control valve is going to decide whether you swing left or right and how much flow is coming to this motor by proportioning it as the operator. So that's our main connections to the DCV. That's going to turn this bidirectional motor, and as it turns, there's a spline shaft that drives out of the barrel and into, in this case, a triple reduction planetary gear set. And at the bottom of that gear set is a pinion that meshes with the big ring gear that's mounted in the car body of the excavator. So as the motor pinion turns, the whole upper structure will swing around as it rolls inside the fixed gear that's part of the car body of the lower structure. And on this motor on the top here, this is where the K-strain comes off of this one, runs back to the tank. This is where our makeup connection or anti-cavitation line that would have some back pressure because it's teed into the system upstream of the oil cooler. So there might be 50, 75 psi in here depending on what temperature the oil is and what the engine RPM is, etc. But a little bit of sort of boosted drain pressure to work with these anti-cavitation check valves, because swing motors on excavators are prone to cavitation. What can happen, especially if you're swinging downhill and you've got a load of material and you're casting material, well, when the operator decides to stop swinging, they're going to put the control valve back in the hold position, but we don't want the machine to stop instantly. If it does, all that inertia is going to cause the track on the upper side to lift and come slamming down, and it would be abusive to the machine, and it would be putting a lot of load on that pinion and the teeth on the ring gear if we were trying to start and stop the machine instantly. So when the operator recenters the control valve, when they're done swinging, these ports are blocked by the DCV spool, but because of the inertia of the upper structure of the machine wanting to swing, it's going to start turning that pinion. And this reduction unit is now going to become a speed increaser, and it's going to start spinning that motor, and the motor is going to start acting like a pump. But it's a pump with no oil because the operator has recentered the control valve. There's no oil being fed to it. So there's a potential to cavitate and damage the rotational parts of the pump, or sorry, of the motor when it's acting like a pump. So that's where this makeup or anti-cavitation line comes in with maybe 50, 75 psi. And when that scenario is happening, then cooler return pressure will push that check valve open and keep some oil flowing to the swing motor itself. And that will keep it from getting damaged in that scenario. Now, what's going to bring the machine eventually to a stop is the relief valve. So there's normally 2 relief valves in here. This one's only got 1 installed in it. But what you'll find with the swing function on an excavator, there are port reliefs installed right at the motor. So if I follow the lines up from the swing motor to the control valve, that is these lines here. When I get to the control valve, I see there's no port reliefs here. In other functions, there's actually port reliefs, like for the bucket, stick, but there's no port reliefs in the DCV for the swing function because we have relief valves at the swing motor, and on this 307, the relief valves are at the sides here. But we've got a relief valve set in there, but they don't call them port reliefs, they call them swing reliefs because they're actually set much lower than the main relief on the machine. So for this 307, the main relief for implements is set around 4,000 psi, but the swing reliefs are only set about 3,400. So that makes the swing intentionally weaker because of that pinion at the bottom and the teeth on the Rotac gear, on the ring gear. They don't want to put that under as much stress as we start breaking teeth. So a skilled operator is going to be using the swing function to position the machine, and then they're digging and moving material with the bucket functions. They're not backfilling a trench with the side of the bucket. That's abuse to an excavator, and they wouldn't be too successful at that anyways because there isn't a lot of power in the swing function because of the setting of these relief valves. So these relief valves are set intentionally low to prevent damage to the reduction unit and the pinion and ring gear that are swinging the excavator. So we've got 2 anti-cavitation or makeup valves, which are just check valves that are going to let that cooler return back pressure in during a swing stop. And then we've got 2 swing reliefs mounted at the motor, and they're going to basically give you a nice soft cushion swing, because again, when you stop swinging and you put the control valve back in the hold position, that drive is going to want to turn that motor into a pump. The ports are blocked, so the pump is actually going to be pumping oil over the relief valves, left or right, depending on which way we're coming to a stop. And that's what gives the excavator its controlled stop. It doesn't stop too abruptly, it stops nice and smooth. And you can sometimes hear that hissing of oil going over the relief valves while you're in the cab when you're coming to a stop. Kind of a whooshing sound as the oil crosses those reliefs. Another feature or function of some machines' swing drives is an anti-reaction valve built into the motor. And because of the clearance in the teeth on the pinion on the bottom and the ring gear and the car body, when you come to a stop, some excavators are going to want to kind of clack back and forth. Once the machine kind of stops, because we're building pressure on the return side, pushing oil over relief as we come to a stop against, basically blocked ports by the control valve, that's sort of storing pressure, and then it can kind of want to swing the machine back once it finally comes to a stop, and then you can kind of get this bouncing back and forth. And it makes the machine kind of seem like it's got a lot of slop in the pinion and the ring gear, and that can actually be the case when you get an excavator that has got a lot of that kind of motion when you come to a stop. But what they've done hydraulically to try and prevent that sort of click-clack back and forth on the pinion and the ring gear and make those gears at the bottom last a little longer, as they put in this anti-reaction valve. And what the anti-reaction valve does, it kind of senses when you've stored that energy and then it starts to release. And when that release of energy happens, the swing anti-reaction spool actually combines, it connects the 2 work ports together briefly on the motor and just kind of releases all that stored energy, so you don't get that kind of continual clacking back and forth. That's often an option on an excavator. This one had it. Our 307 appears to have it too, as well in the swing drive. Another option that this machine doesn't have, but I believe our 312E excavator out in the yard has it, is something called fine swing or free swing. And when you've got fine swing or free swing, you'll have an additional solenoid mounted on the motor somewhere in this area. Sometimes it'll be a manifold where the two hoses connect for swing left and swing right, and there'll be a solenoid there, and what it will do is open a little leak. As soon as the switch is on, it opens a little controlled leak between these two work ports, and that's for craning applications. If you've got sling chains and pipe or something, and the excavator's moving pipe into position on a civil engineering project, and you swing into position. If you stop too abruptly, well, that pipe's going to be swinging, and everybody's going to be on coffee break waiting for it to stop swinging. So what fine swing or free swing does, by opening that little leak between the two work ports, when you come to a stop, it allows the load to kind of drag the upper structure of the excavator and take some of that energy out, or inertia out, and then the time it takes to stop that load from swinging back and forth will be reduced. The other thing I want to talk about in this swing device is an internal brake. So in here there's a bunch of coil springs in the top here. Sometimes they use Belleville springs, but often it's just coil springs. And I see some discs and plates. So this barrel of the motor has actually got an external spline on the top end of it, and then there's a spline in the housing, and we've got a wet multi-disc brake that, when the springs apply a piston and compress the discs and plates together, that locks the barrel to the housing. So this is a spring applied oil pressure release brake, and here's the port that releases that brake. So this would be pilot pressure coming in from the pilot system, and every time you touch an implement, whether it's swing, stick, boom, bucket, the logic of the main control valve will send pressure here, or it may be a solenoid and switches on some machines controlling the sending of pressure to the swing brake, but that will release that swing brake. If you're traveling and only traveling, then the swing brake is applied, and when the machine is parked, obviously the swing brake is applied. So it keeps the upper structure. If you had a bit of leakage in your motor or in your control valve, it keeps that upper structure from wandering if you're traveling on a side hill, or if the machine's parked on a float trailer heading down the highway. We don't want the upper structure wandering left and right as we go around corners. So the brake helps hold the swing pinion locked so the machine can't swing. On really old excavators, there may actually be a hand brake in the but for the last 25-30 years, that's typically going to be a spring applied brake built into the motor unit itself. The 307 has this exact same brake built into the motor device and swing device, and this line coming to the side here is actually our swing brake release. So every time you use, again, any implement function, not just swing, because they don't want you tearing if you're cutting a trench and you're kind of putting a side load on the bucket, they don't want you tearing the discs and plates out of the swing motor. So they release that swing brake with pilot pressure anytime you use any implement function. So stick, boom, bucket, or swing. Again, if you travel, that doesn't by itself release the swing brake. But if you travel and use implements, then your swing brake is released. And if you turn on fine swing, if you've got that option for craning applications, then the swing brake gets released full time by a second solenoid. And it's important to note that it isn't the brake that stops you swinging. Again, what stops the machine from swinging is the fact that the operator is going to let off the control and put the control valve spool, then the centering springs are going to center it back to the hold position. The work ports will be blocked, and therefore we've basically hydraulically locked the motor so it can't turn, and then it's going to start to pump oil over the relief valve one way or the other till it comes to a stop. Then there's generally an orifice that's delaying the application of the brake for the brake springs to push the piston down and clamp the discs and plates together. It's going to have to push oil out through an orifice to get to drain, and it just drains into the case drain passage when it's doing that. but it's generally they call it a brake delay valve. It's mounted on the side of the 307 motor here. So when oil comes in to release the brake, that's instantaneous. But when oil is draining out to apply the brake, when you stop swinging, that can take about 10 seconds to actually apply that brake. Because again, there isn't enough friction material in there to last. They don't want that brake stopping the machine. It's not a service brake, it's just a parking brake. So there's generally an orifice effect to let the oil out, and it can take some time. On some machines, there's a solenoid valve that's releasing the brake, and in those machines, the delay might be electronic. It might just be the solenoid energizes to release the brake as soon as you touch any implement function, and a switch might detect that you've gone to work with one of those functions. But then turning the solenoid off may be delayed by 5 or 10 seconds to allow the machine to come to a stop with trapped oil, doing dynamic braking, and then the parking brake will come on, and that's going to save the life of those distant plates.